Okay, so welcome along, ladies and gentlemen, to your weekly SETI seminar series. Today we're very fortunate to be joined by Andrew Nelson, who's come to us from the Mojave, where he works at XCOR. Andrew did a bachelor's in electrical engineering at Ohio University in Athens, and then also did an MBA in finance at the Sloan School of Management at MIT. Andrew has worked at NASA Ames, just across the road, on a differential GPS project. He's also worked for 15 years in aerospace companies at KSC, including the MITRE Corporation. And then he worked at Morgan Stanley and Lehman Brothers. And since then, he's been working at XCOR and is now the Chief Operations Officer at XCOR. And tonight he's going to talk to us about the future plans of that company and the future of the suborbital industry. So if you'll join me in welcoming Andrew.
Well, thank you very much for having me here tonight. It's very exciting for me personally to be at the SETI Institute. I was mentioning earlier tonight to Adrian that when I was 14 years old, I was living in Delaware, Ohio, where I grew up. And that's where the Big Ear radio telescope is, where the WOW signal came through. And so the SETI project that sort of very exciting to Dr. Ehrman with his signal and the big WOW on the chart. So I remember that vividly as a 14-year-old, and although I was already interested in science and technology, I thought, wow, just like everyone else did, there's something is really out there. And it also was very helpful for the radio telescope people because we were golfers and we stopped hitting golf balls at the radio telescope because we actually thought it was really cool after that. It was at the Delaware Country Club. So I guess there was positive effects from SETI, at least on the dents on the telescope. So, but no, it is very fortunate for me to be here. It's exciting to come here. So tonight I'm going to talk to you about a little bit more than just XCOR and the Lynx, although we're very proud of what we're doing. My talk tonight is from Andrew Nelson. It's not from XCOR Aerospace. So anything I say or do tonight is all of my own volition and should not reflect positively or negatively on XCOR unless it's positive, and that's fine. So I do want to point out a few folks in the audience. There's a few XCORians. If you can raise your hands. You got Kaki and Jeremy, and we're also here at this time. We were here at a conference that was hosted by the Southwest Research Institute and NASA Ames, the Next Generation Suborbital Researchers Conference, which Alan Stern and Cindy Conrad, where's Cindy? There she is, organized and did a really great job. Over 400 people at the Crown Plaza talking about next generation reusable suborbital vehicles and experiments, and it was really great to be there. So tonight I'm going to talk to you about the future. I'm going to talk to you about a potential vision of the future. I hope it comes true, and but it starts with the long-term vision that there is a multi-trillion-dollar marketplace just waiting for us to grab hold of in low Earth orbit and in our solar system. Much as the early days of the internet, the ARPANET, when it was first conceived, no one, I think, could have imagined that the fundamental impact that system has made on our lives and in the world. It did truly create a multi-trillion-dollar industry. It's very diverse. It's very fragmented. You couldn't really point your finger and say, that's the marketplace, because it's so broad. But I think that we are on the cusp of those early days of the ARPANET in reusable space vehicles. So what I'm going to talk to you today about is sort of that path that I see going forward. So first I'm going to talk a little bit about what is a $1 trillion marketplace, because trillion is a really big number. And then I'm going to talk a little bit about visionaries, use some analogies on how perhaps our industry can get to that large number. And I'll talk a little bit about the transformation of space. Talk a little about the history, the past, as well as the present, and potentially the future. And then I'll spend a little bit of time on Lynx at the end and how perhaps Lynx is the seed, one of the seeds that will create this vast potential jungle of space enterprise. So, the beginning of the big, huge canopy. So what is a $1 trillion marketplace? Well, by definition, a trillion is one with 12 zeros on the back of it. But let's just figure this out. Do we think the global electricity generation market today is a $1 trillion marketplace? Raise your hand if you think it is. Yeah. Now, be careful of definitions. I thought the same thing as you did. But in fact, it's only about $300 billion a year, according to BCC Market Research out of the United Kingdom. And of course, they have British accents, and they must know, and they're always accurate. Right, Adrian? Because that's what Americans always think. So, but electricity generation is not as big as perhaps I thought it was. So we'll go in and we talk a little bit about the evolution of the market for electricity. And Google has done a lot of work on this. And Google did this story or study about the Clean Energy 2030. And they talked about the growth and the phasing out of certain types of energy sources. And I've noted one was wind. And they want to generate in the future 380 gigawatts. This is just in the US for wind. But interestingly enough, it's going to cost $130 billion to create the transmission capacity to get that energy out to people to use it. So just remember that $130 billion number, because that's going to be an interesting one. So then I thought, well, gee, there's a lot of airplanes flying around the world. I started in the aviation industry. So how big is that market? So, okay, you guys are sort of clued into this. Do we think it's a $1 trillion marketplace globally? No, no one's going to raise their hand. You guys are smart. Okay. In fact, it's about $500 billion. And this was actually after about a 12% decrease from 2008 to 2009. But even so, it's really not close to $1 trillion. So, but then I thought, okay, well, what about e-commerce sales? E-commerce retail sales. I would hope that that's a $1 trillion marketplace. So who thinks e-commerce globally is a $1 trillion marketplace? Go on, a couple brave souls out there. You're really close. I didn't talk about market cap. You're really close, though. It's a couple years from now, Goldman Sachs, of course, we always believe and trust Goldman, $963 billion. That's pretty close enough for me. I'm the marketing guy at XCOR, so yeah, round up. Significant figures, that's good. Always round up, never round down. So that's a lot. There's a lot going on in the e-commerce world. But how do you really create big markets? You really need to create fundamental change. You need a lot of vision. So if we use some analogies about marketplaces and relate that to future space, I've done the inverted pyramid. If you think about communications, for example, there's a fellow in our industry. His name's Brett from Blue Origin. Help me out. Brett Alexander. Thank you very much. Uses the analogy with the communications industry. So when you go to implement infrastructure, laying dark fiber, lots of fiber optic cable, it costs you billions of dollars. And you probably have 3 to 10, 15 players in those marketplaces. But because of that big investment in the core infrastructure, you'll then have a number of platforms that will start to lay on top of it, whether they be wireless communications networks that then connect into the fiber optic backbone, or you have internet or video on demand, et cetera. These platforms start to develop, and you can have hundreds of these businesses, and they roughly cost perhaps $10 million to $1 billion to implement, depending on really what you're talking about. Maybe you're developing the iPhone or something of that nature. But then you have on top of that a number of applications and services and products. And those are in the hundreds of thousands and millions. And those, of course, you can implement for next to nothing or a few tens of millions. Being in Silicon Valley, you're all familiar with these numbers, but pretty soon, if you start doing it the right way and you get some growth, you will have a very diverse multi-cent-billion, if not trillion-dollar marketplace. And so that's really where I see or hope space is going to lead. But how do we get there? So now comes vision. So visionary. Visionary is an adjective, it's a noun, having or marked by foresight and imagination, or one who can envision the future. So in the world of visionaries, I certainly put the Wright brothers. That's where it all started for us, I guess. A very short flight, but pretty soon, the China Clippers were crossing the Pacific. And trust me, Pan Am and Juan Trippe were way out ahead of their time. And from all the accounts I've read in history, it was quite an adventurous trip. Certainly the first refueling stop off the West Coast was in the middle of the Pacific before you got to Hawaii. Hope they know where the ships are when you land. I guess that's sort of like on-orbit refueling depots or something. And then, of course, sort of the DC-3 really helped revolutionize things. And eventually, with no more than a handshake, a deal, 747 was produced between Boeing and Pan Am. And, of course, the aviation market that we know today was created. So there are certainly early steps to space that we at XCOR and others are standing on the shoulders of. The Bell X-1, the X-15, the early work on the Dinosaur, and of course the Space Shuttle. Without these early steps, we would not be where we're at today. Perhaps this is those sort of core fundamental bottom of the pyramid investments. For us at XCOR, our people have read all of the papers we can find on these vehicles, and we're trying to use them every day. So now we have a transformation of space. And what is transformation? It's a dramatic change in form or appearance. So let's sort of take a step back and look at history. This was space, 1940s. Love that look. You had the von Braun wheel, orbiting space depots, space planes. And then, of course, 2001: A Space Odyssey. I keep going back to Pan Am. It was my first job out of undergrad, working for part of the airlines down at Cape Canaveral, actually. So you had the Pan Am Space Clipper. Well, that was very exciting. And I think, perhaps, history as we saw it then can be our future. I think it would be very exciting. But how do you get there? Well, let's talk about the reality of space through 2012 or 2010. Well, first we started with Mercury and Gemini. We went up to Apollo, Skylab, shuttle, and the shuttle at ISS. I always think that looks like an interesting, I love the ISS and the shuttle, but when I first saw that picture for the first time, I thought, man, I thought it was going to look different. But anyway, all the artistic images look more symmetrical for some reason. But this is the new reality. The new reality is suborbital as the enabler for that historic picture that we saw before. So what are we really talking about? We're talking about people like XCOR, Virgin Galactic, Blue Origin, Maston, Armadillo, and others who are trying to take vehicles and fly them a few times a day, twice, 3, 4 times a day, every day of the week, maybe one day downtime, and gain experience of thousands of flights a year going up to the edge of space and back down, and learning what full reusability is. And from that basis, we hope to transform these suborbital vehicles into fully reusable orbital vehicles, which can then lower the cost of space access from tens of thousands of dollars per pound or kilo, however you want to measure it, to hundreds of dollars. And when that happens, I think we're going to have a really exciting marketplace. New applications are going to spring forth. We're going to have that dramatic change, whether it be, and in any industry, it could be a regulatory change, it could be a change in technology, but certainly a change in the cost, a fundamental disruption of the marketplace. So lowering the cost to orbit with full reusability has always been a dream. There's been dreams of the National Air Space Plane, Skylon, Sanger, we know them all. And they're very exciting. Just grab these off the internet. And I think that that is going to be where our future markets are going to be. And when you have the ability, say, every day of the week, fly to orbit and put a few thousand pounds in low Earth orbit for under $1 million, you're going to start to enable very interesting things like space-based solar power. Well, what do we say the original electricity generation market was? A few $100 billion, and add some inflation. I think that you have a very exciting marketplace right there. So that's the first part of our $1 trillion marketplace. We are not going to, of course, completely replace one for the other. But when you can see an investment in the sort of low tens of billions to generate an economic return of 15 to 20 or $30 billion a year for that investment over a period of 10 or 20 years, then people will start making those investments. Certainly they put a lot of money into a lot of satellite constellations back in the day, and they showed the cash flows, and those large investments were made. Then we get to do things like very fun stuff like solar sails. We can race across the solar system, explore things, and go places, and find new resources that are very important to us. Perhaps, you know, the elusive Platinum Asteroid, right? We've all heard about mining in space. But we actually have someone here who's pursuing that venture. There he is, right there. So we have a member of the future $1 trillion enterprise now. And when you start adding this up, you see a vision of the future that's quite exciting. And then we talk about applications that we never dreamed of. I'm amazed that every day at XCOR, it seems like every day, I get phone calls and emails, and Khaki gets them and others, and they say, can I use the Lynx and do this? I guess. Don't see why not. Doesn't outgas and won't kill my pilot. Doesn't have Ebola in it, does it? Good. Okay, we can do that. I certainly, my safety officer, Randall Clegg, who I think I saw walk in. Is Randall here? There he is. Randall sometimes puts up with me and sometimes doesn't, but I thank him for putting up with me when he does. Because it is an exciting time. But you know, when you take those first steps and you do what we're trying to do with Lynx and fly every day of the week, and from that experience, and we've purposely designed and pursued Lynx in a certain way because we think it's the logical stepping stone to a fully reusable orbital system, that we see the future ahead. I get crazy questions sometimes like, well, gee, isn't there a lot of space junk up there, and aren't you going to have a problem with that? That's a business opportunity. Someone pays me to be the garbage truck of space, I'm all over it. So, and I think someone will actually make a lot of money doing that one day. But there are challenges to the future reality. There truly are. You know, the future reality is going to require government help, government support. Anchor customers are very important to fledgling industries. We saw that in the 1920s with the Mail Act that really helped the airline industry. We've seen it in other industries as well. But if we don't have the right government hand, we don't have the anchor customer, but we have an anchor, that's not going to help. There's a great political cartoon. It shows, many of you may have seen it, it shows the early Wright Flyer. And Wilbur and Orville are sitting in it, and he's got bricks up the side, and he's got a big helmet and football pads, and you know, et cetera, and the one guy sitting there with his briefcase and it says FAA on the side, you know, and the other brother is saying, but it'll never fly, and the FAA says, but he's safe. You know, okay, that's good, but you know, we don't need that kind of help. So there are some challenges to this future reality. I just want to, you know, all interested people. And first, I think, is really the space launch system. I think that it perhaps is not the right system for the right time. I think there are other ways of doing things that we need. Do we need the other big rocket? I'm really worried that it's going to take resources away from a mission that NASA should and be performing, which is science and true sort of early exploration. NASA needs to become a really good customer of reusable systems. And building another big truck to low Earth orbit, I don't think is really what we need, or even a little bit beyond. I think that there are sometimes congressional interference that comes into play. We see this sometimes because there's a perception that the NASA budget is a jobs budget, and it's not an investment budget. If Congress even thought halfway between where they think today and the way some of the venture capitalists and investors here in Silicon Valley think, they wouldn't think that $1 in is $1 out. $1 in should be $100 out. That's what they should be shooting for. And there will be some bad investments. But we really need to think about how to enable industry and not just, protect certain congressional districts. And then I think ITAR reform is very important. And people are really working hard on ITAR reform. But I can tell you, when you have a system that is so gun-shy to make a decision that they label everything a satellite, even if it's only in space for 56 seconds, it's a problem. Oh, I'm sorry. It's the International Trafficking in Arms Regulations. It's what, and there's another one called the Missile Technology Control Regime. And I don't want to sell, really good rockets to people who want to point them back at us, and so certainly that's not the question. But when you have a suborbital vehicle, for example, whether it's Virgin Galactic or Armadillo, and it's above the Kármán line for, like I said, 56 seconds, and then they label it a satellite, and hence on the export control list, it baffles me, and it kills jobs. It kills jobs dead in their tracks. So it doesn't mean that we can't get an export license. It just means it's a lot harder. It means that investors don't want to step up. It means that it's more challenging to take risks. So we do have challenges to the future reality, but I think we can definitely overcome them. So a few words about Lynx. So Lynx, yes, it's a wild cat with yellowish brown fur, a short tail, tufted ears, and found chiefly in North America and Eurasia. But it's also a hot rocking space plane from XCOR Aerospace. So that's the definition that I like. So here it is. We believe it's the first step to the future. This isn't an advertisement for XCOR per se, but I'll just tell you, we take off from the runway like, if you don't know what Lynx is, we take off from the runway like a normal aircraft under rocket power. After about 15 seconds, we burned off enough fuel where our thrust-to-weight ratio goes above 1.0, and the nose tips up, and for the next 170 seconds more, you're on the ride of your life. Accelerating up, achieving 1,000 meters per second upward velocity, about 3.5 Gs going up. Engines cut off at about 200,000 feet. Silence, weightlessness. Feel it for 3 or 4, maybe 5 minutes, depending on how sensitive you are. You go over up at the top, peak out at 350,000 feet or so. Curvature of the Earth, thin blue mantle of space. You look down below, no lines on the map. The blues, the browns, the greens. It's a life-changing experience. You come back in, pull out, feel those 4 Gs through your chest, down through the seat. You pull out, long glide home, and you realize that was a pinnacle life event. And that's what the first step to this future trillion-dollar marketplace is. It is the daily, regular, safe, repeatable flight to space that will eventually get us to this future that we hope we can all enjoy and enjoy the fruits of. So there are a few space visionaries, new space visionaries, that if you don't know who they are, I want to introduce you to. So first, Bob Bigelow. So Bob Bigelow is making interesting things happen. Industrialist, real estate developer, hotel chain owner, Las Vegas, Nevada. Built himself a few 100,000 square foot facility on the north side of Vegas. revitalized a bit of a neighborhood up there, and he's building inflatable space HAPs. Interesting enough, he's already got 2 of them up on orbit, scale size. And I think, can you still go online and see the things floating around inside? For a while, they had sort of an online feed, you can do it, but I don't know if it's still active. Of course, you got Bert and Richard. Our hats are off to them. They showed the way. We're very excited. Still in the industry. Bert's got a new project, which we all are aware of with Paul Allen. You got Dave Maston, our next door neighbor. This was the cover of Aviation Week and Space Technology magazine, where Dave was a representative for the new Rocketeers, who were the People of the Year from Aviation Week. Jeff Bezos, Amazon fame. Jeff's doing Blue Origin, putting his own money in. Wants to do another form of fully reusable orbital systems, starting with the first stepping stone of suborbital. Everyone knows of Elon, famous in this neighborhood. And Elon is following his dream. He says he wants to retire on Mars. And my boss, Jeff Grayson. Jeff is a man of deep feeling, integrity, and high intelligence. And he's a great leader. And what Jeff is doing and our team is sort of showing the way, very much like the early pioneers here in Silicon Valley did, from the garage. Really doing it the way that folks in these neighborhoods know how entrepreneurship is performed. Now here are some of my personal favorites. Of course, the XCOR team that I'm very proud to work with. It's a ragtag group of very hardworking, excited, energetic people, and we're growing every day. So if there's anyone out there who likes to turn a wrench, and get their hands dirty, and live out in the desert, well, send us your resume, because we are hiring. Got a group called Space Expedition Curacao. Back in the early days of aviation, there were a bunch of people who saw these newfangled contraptions flying around, barnstormers and whatnot, and they said, you know what, we can create a new form of transportation, the early days of the airlines. And very much like those early aviation airline pioneers, Space Expedition Curacao is trying to create the first space line. They're trying to beat Richard and Virgin Galactic to the punch. And it's a group out of the Netherlands that has a former chief of their air staff, equivalent of a 4-star general. There's an active Air Force test pilot who was trained at Edwards Air Force Base, part of the Dutch Air Force. 2 very successful entrepreneurs. And then a fine group of people. Alan Stern, one of my personal favorites. An innovator, a visionary. Alan is so busy, I have no idea how he does it all. I thought I had a lot of balls in the air. He's driving a spaceship to Pluto at the moment, and I know about 30 other projects. Planetary Science Institute in the Citadel, trying to use suborbital vehicles to do very interesting telescope-based studies, and really going out and doing what they feel is right. Jeff Mamber over at NanoRacks, very interesting fellow. Been in the commercial space industry on and off for a number of years. He's already got racks on the International Space Station. You can get your local high school students or your kids or your grandkids, give them $5,000, $10,000. Jeff will get it up to the International Space Station for you and have astronauts run the microgravity experiments. And then bring the thing back. That's pretty amazing. And Jason Andrews. Jason is, I'd call the all-around entrepreneur. He sees an opportunity, he goes after it, always enthusiastic, hardworking. But these are just a few of the people in the industry that we serve, and we're happy to serve with, that are doing things every single day that are going to affect all of your lives. So that's the culmination of my presentation. I want to open it up for questions, but I guess the final The final thought I'll leave you with is that the steps to a future space-based system is already started. The trillion-dollar future marketplace that the internet is today, we will have in 15 or 20 years, I think. And it's all starting with folks down in Mojave, in Texas, in Florida, and every other place, Colorado, where we're trying to do commercial space. But just flying up and coming back, flying up and coming back, learning those lessons, making those mistakes. And there will be mistakes. There will be bad days. But we'll keep moving forward. And then we'll all enjoy the fruits. And that's it. Thank you very much.
And Andrew, can I kick things off with the question about the engines? And maybe this might give you an opportunity to play one of those videos too.
Oh, yeah, I got some videos. Yeah, sure.
Can you talk about the engine of the Lynx, and is that currently, and how is that related to the engines that you're using at the moment?
Yeah, sure. We actually have been firing what is, in effect, the Lynx engine since 2008 now. Yeah, roughly 2008. The Lynx engine is a derivative engine of the engine that we flew on a vehicle called the X-Racer, which was a technological demonstrator for potentially basically an entertainment application. But the 5K18, it's a liquid oxygen kerosene engine, produces about roughly high 2,800, 3,000 pounds of thrust, and fully reusable, driven fuel and oxidizer is pumped in the engine with a piston pump versus a turbine pump. And the piston pump, we feel, is really the key, one of the keys to long life. We have now hours of runtime on our piston pumps with little sign of wear and tear. Whereas if you look at the traditional way of pumping oxidizer and fuel into a rocket engine with a turbine pump, I think you're good to get 20 minutes of operation out of them. And they only cost a few $1 million a piece. But we rely on the automotive industry for our manufacturing base, some of our contract manufacturing. And when your supplier is making millions of items, the costs go down. And it turns out the precision goes up as well. So that's one of the keys. If you notice on this picture, this is a special paint scheme that marketing came up with. But you see sort of the green engine swoosh across the back, and that sort of signifies our green engine technology. I say green, it's non-toxic. It doesn't use nitrogen tetroxide or hydrazine or anything like that. One of the keys to really driving this industry in the future is going to be getting costs down per flight to very low numbers. It's all about maintenance man hours, per flight, touch labor. The lower you can drive that and maintain safety, the better you're going to be operational margin-wise. So if you don't use toxics, you're naturally better off than someone who does, especially from a cost perspective on a day-in, day-out basis. So the engine. Yeah. I can actually show you a couple engine videos if you'd like. So here's this is the Lynx engine firing in a pressure-fed mode. Sound. Okay. So this is at our in Mojave, just across from our hangar on the other side of the runway. There you go. Power. powered by air gas. I have to say that they're one of our sponsors, so they give us really good prices on liquid oxygen. So so that's the 5K18. But you know, one day we're going to have to go to bigger engines, bigger heights, and it turns out that we've largely solved that problem already. So here's a real short video. Martian death ray. Little story behind that video. So the first time I played that video, I was still at Morgan Stanley, and it was a big trading floor, multiple screens, etc. And I got this thing and they said, the sound's not very good. Make sure you turn it up really loud. I got traders doing the prairie dog. Yeah, what the hell's that? It was hilarious. It played about 20 more times on the floor that day, so because everyone couldn't stop. They said, I want a copy of that. So that was great. But so to answer your question, there's a couple engine videos. Yeah. So, what other questions do you have?
Is that the same fuel in both cases?
No, the first one was liquid oxygen and kerosene, and the second one was methane. So.
If you have a question, just put your hand up, and we'll get around to you with the mic.
Oh, yes.
The industry is focusing on innovating by itself-ish, not relying on NASA. We can do things better, faster, cheaper, et cetera. What role do you see, if any, for continued transfer of knowledge in the other direction, NASA innovating, not just as a customer for the industry, or what do you think NASA should focus on that the industry would be willing to take?
Well, I think the premise of the question is perhaps not exactly accurate. We like working with NASA on technology projects. We actually have done a number of projects with NASA. Some of our very early work with, we have a non-flammable composite material that we developed was with NASA, and we continue to want to further develop that with NASA because they're going to need non-flammable composite tanks to wrap around liquid oxygen, liquid hydrogen, just like everyone else is. And we think we have the solution. So NASA is, I think, very good at identifying or helping to identify key technologies and doing certain leading edge pathfinding demonstrations, thinking big, how to get to Mars, how to do the Pluto missions. So I think that if NASA sticks to that original sort of futuristic looking mandate that they had and sort of get away from wanting to be the trucking company, I think that's the way to go. So, yeah.
Hi.
Oh yeah, someone in the microphone in the back.
Right now, if I buy a ticket to Hawaii on the 747, roughly 1/3 of the price of that ticket represents fuel. It's about 1/3 personnel costs and about 1/3 capital, et cetera. The space shuttle comparable numbers are 1% of the cost of the flight is fuel, and this is a good figure of merit. When you fly one of these things, what percentage of your ticket price is going to be fuel?
I know, but I don't know if I want to answer. Let me answer the question in a certain way. The airlines fly on about a 3 to 4% net margin basis if they're lucky. Okay, and I can't sell that to an investor. There's no way that I can go into someone and say, give me a few $1 million, a few $100,000, $10,000, whatever the ask is, and say, I want you to invest in a 3% net margin business. So we're shooting for net margins in the 30 to 40% range. We need to be like a software company or a social media company, et cetera. We have high barriers to entry. We have a challenging regulatory environment. We have challenging technology. So we can command those prices. So fuel is going to be a smaller percentage of our budget our cost line than the airlines who are flying at 3% net margin. So is it a large number of our total price?
Somewhere between the two ends.
Exactly. So, but yeah. If you become a big investor, I'll tell you. Oh, yes, ma'am.
Yeah, I have a simple question. I know the Lynx is, sorry, 2 passengers, I think you're talking about the Lynx?
It's a pilot and one
One
participant.
passenger.
Yep.
And the Spaceship 2 is 6 passengers.
Yes.
What would you charge per passenger on your 6 passenger if you get to that point?
I don't know.
You don't know, okay.
Whatever the market will
And
bear.
how soon?
Yes.
And how soon?
Well, we actually don't have current plans for a 6-participant vehicle. We very much see the industry not necessarily at the DC-3 or Fokker tri-motor stage, if I can make the analogy. We see it very much as sort of the Blériot and early 2 or 3 seat airplane market. So we think that that we've got the right size vehicle for the marketplace. It's important for us that we fly at 100% load factor. So if we don't have someone to fly, we don't fly. But we don't have plans currently to have a larger vehicle. It might be that in the future what it turns out to be is that our future orbital system, which we envision as a sort of a 2-stage system, the first stage could be a very nice DC-3 of the suborbital market.
I flew the DC-3. I know what it's like.
Yeah, so have I. Actually, my university, at Ohio University, had a flying laboratory as a DC-3. I love flying the DC-3, so it was great. Next, I had someone over here who was
Virgin Galactic has, of course, flown a vehicle and a few times, but if this were an easy thing to do, I would have expected to see a whole lot more flights by now. Mm-hmm. And yet after an initial rush of excitement and a few flights, they sort of kind of shut down almost, it seems. And so I'm sort of curious as to what kinds of logistical barriers and what other barriers have sort of prevented them from really taking off in a literal sense.
Well, I'll have to let George Whitesides answer your questions as to why Virgin's not flying yet. I can tell you our flight record, though. We've flown 2 earlier rocket-powered aircraft, 66 manned rocket flights. We have many thousands of rocket engine firings now. We are an engine company, first and foremost, and you should never design an airplane until you know the engine works. That's our philosophy. There was a very light jet maker who made the same mistake, that he designed an airplane before they had the engine working, and that company is now not in business. So we believe that propulsion's the key. We've locked that in, and now we're designing the vehicle around the propulsion system. So we're looking to have flights, beginning a test flight program, hopefully by the end of this year, get a little air under the gear, and then advance more into 2013 with a full flight test program. And that's our objective. It is an aerospace project, though, so not promising those dates. But you'll have to ask George about Virgin.
Hi, behind you.
Oh, yes.
Hi. Speaking of the design of the Lynx,
Yes.
the front windows are very interesting looking, and I'm thinking in terms of a re-entry perspective, and I was wondering if you could talk a little bit about that.
It's got that cool 1940s look, doesn't it?
It is very Buck Rogers. I appreciate that.
Yeah, absolutely. Well, if you look real close, let me see if I can expand one of the pictures here. Where's my slideshow from current slide? Okay. So if we look real close, I'll do it on your side since you asked the question. You see you got the flat panels and you just have this sort of curved surface there. The vehicle actually has 2 windscreens. The first inside curved windscreen is for the pressure vessel. You want to have, the cockpit should be an 8,000 to 9,000 foot pressure altitude type shirt sleeve environment, although you will wear a pressure suit as a backup or as a safety device. But the curved surface is better to hold pressure. The The external surfaces are for strike and thermal, thermal panes. So what happens though when you create those surfaces in a complex curve shape in the right material, the windscreen becomes more costly than the rest of the plane in its entirety. So XCOR being XCOR, we have $500 panes. So, but it works just great. It does have that cool look to it. But they're basically there's two functions there. So. Yeah, we got a gentleman in the back.
You mentioned NASA's role in this and a partnership basically with industry. Do you think NASA is picking up this role of that they really should be focusing on the 10 to 15 year out research area and opposed to being a space bus of just hauling things in orbit? Because I think that's basically what I understand NASA's philosophy, that they moved away from the barge to orbit philosophy.
Yeah, I think that as any large organization, the right hand sometimes doesn't agree with the left hand, or the right foot or the left foot for that matter. So I see the Space Launch System as an attempt to return to a big build your own rocket project, which I really worry about that pulling a lot of resources from the rest of NASA, much as Constellation.
Did that really get tabled with Obama's viewpoint against George Bush's vision of
Constellation
first and then Mars?
Yeah, no, in fact, well, we thought Constellation was dead, but SLS is sort of son of Constellation, I think. Others can speak more eloquently about the Space Launch System, but I think that we need to worry that that system could draw a significant amount of resources over many years away from what I believe the core mission of NASA should be.
I thought it was dead.
No, it's not. The Senate Launch System is. I'm sorry. The Space Launch System is alive and well. So.
So far, every manned spacecraft that's flown more than 15 or 20 times has killed a crew. And I'm wondering if the suborbital industry has a plan to keep Congress from killing suborbital commercial flight after the first time or two that an accident occurs.
I would disagree with the statistics. They aren't that bad. Historically, they aren't that good, but they aren't that bad. I think shuttle is about 1 in 100, roughly.
2 accidents out of 135 2 accidents out of 135 launches for shuttle. Most people don't know it. There have actually been 912 manned suborbital flights in history,
right,
and 10 accidents.
Yeah.
So the accident record is not good, but it's not god awful either.
Right.
And we can do better.
Randall Clegg, my safety officer. Thank you. Saying that, the Commercial Spaceflight Federation and all of the industry players recognize that it's not a matter of if, it's a matter of when. However, we also take the view that in the early days of the railroad industry, there were some very dramatic accidents, and we have railroads today. And in the very early days of aviation, still today, there are a number of accidents, and we still fly today. So we don't see an accident killing the industry, even if we kill a few people. We don't want to. Absolutely not. In fact, all of the XCOR employees have an option to fly on the vehicle, and they all want to fly. XCOR employees that want to fly. There you go. Jeremy's all over that. So,
Who's first?
yeah.
So who's going to be
I
the
can tell you
first
who's not
pilot?
first, and Jeff Grayson's not first, and he wants to be, but we've told him no.
Who's going to be the first pilot?
Rick Searfoss is a 2-time space shuttle pilot, 1-time shuttle commander. He's our chief test pilot, and he will be the first one to fly the vehicle, probably the first one to fly the vehicle 100 times. So, so Rick is a trained Air Force test pilot, although he went through Navy test pilot school. So he's got both. He's got both sides of the fence covered there. He was a trained test pilot and shuttle pilot and shuttle commander. So we feel very fortunate. He also flew the X-Racer 40 times, and he flew the Easy Rocket 3 or 4 times. I can't remember how many. 10. Rick has the third largest number of rocket-powered flights in the third or fourth number ever. So he's very experienced.
In addition to the vast number of opportunities in microgravity applications, I've always found the idea of point-to-point transport interesting.
Yes.
However, the economics are always a bit challenging. Do you see any way the Lynx, with what I assume must be a airport-friendly takeoff opportunity, being able to change that?
Not the Lynx. The Lynx doesn't have really good cross-range capability. It goes up real good and it comes down real well, but it doesn't go sideways too well. It only has about 180 seconds of fuel. So even we try to keep subsonic and we sort of go to 45-degree angle and we pulse it and you don't get going too fast. I think we projected it doesn't go very far. So I'd be hesitant to try to. I guess we could go to Cal City.
What do you think about the business in general of
Yeah,
point-to-point?
you know, it's a very good question. I don't mean to make light of it. Point-to-point to me is something that's going to happen well after we're bringing all of you to orbit. And let me tell you why. It's not just the technology. The technology, if we can go orbital, we can go point-to-point. The problem is that if you start planning a point-to-point service on a regularly scheduled basis, you start falling underneath FAR Part 135, FAR Part 135. And it's called a certification regime. And in order to get something like that certified to fly as a non-experimental or spacecraft, you really have to have millions of flights or hours of operation or whatever, some very large number. And the operational history is just not there. The second part of that problem is that goes back to the 3% net margin issue. So today you fly first class, you know, San Francisco to Tokyo, and I think probably round trip tickets getting near $25,000. Okay, there's not many first class seats, but there's not a lot of people who are going to pay 4 times that or 5 times that to fly point to point in 2 hours. You know, are they going to pay $150,000, $200,000 to go 2 hours to Tokyo? And even then, can I pack the plane full of 100 people at that price, much like Concorde? You know, twice a day? I just don't see it. So, you know, I don't think the market's quite there yet. So we have to really get the experience to drive down the price so we can compete head to head with high net margins at $25,000 per round trip ticket. And I just don't think it's there. I would much rather fly people, you know, to orbit for $500,000 or $1 million and take home my 35 to 45% net margins.
I was first. I was reading that you just had $5 million investment in you. So congratulations on that.
Thank you very much.
And if I was going to place a bet on who would get to 100 kilometers first, should I go with Virgin Galactic or XCOR?
Go to Vegas. Yes, sir.
So, I think I missed something.
Yes, sir.
What do you feature as being the characteristics of this trillion-dollar industry? What will it be doing? Are we talking only about giving people fun rides into space and back down? Are we talking about substituting suborbital flights for commercial flights at 5 times the price? Are we talking about being able to make use of suborbital flights to do research into the characteristics of space and the universe that are much more expensive to do now? None of that sounds like a trillion-dollar industry to me.
No, correct. I see the trillion-dollar industry emerging when we're getting costs to orbit down to the few $100s per pound range. At which point, we enable a few different types of markets. We enable core substitution markets. We enable new markets. Core substitution markets could be the power generation industry with space-based solar power. We could have substitution markets where you take commercial secure communication systems, transmission that currently Shell Oil pays potentially $30, $40 million a year to get data and voice securely out of remote areas where they're operating. And they can now have their own satellite system for $10 or $12 million operational cost a year. Where you have new markets, whether it be the mining, the terrestrial mining, whether it's, or other things that people create or come up with. And there will be an element of new markets with flying people to orbit. But I think that what you're going to find is much like we had no idea what people were going to use the internet for once it became available, they started to solve some of the bandwidth problems. You're going to see that industry grow, and you're going to see both a platform layer laid across getting to space, and you're going to see an applications layer laid across those platforms. And that's going to generate this very diverse, multivariate, trillion-dollar marketplace, just like the internet culture is today. So that's sort of the premise of my thoughts.
There's another point I could add to that.
Yes, sir. Yeah, absolutely, please.
So, in that, the annual energy industry in total is approximately $5 to $6 trillion annually.
Mm-hmm.
And I think over this century, as we migrate from fossil fuel utilization to electric utilization, the opportunities for space-based solar power as an en masse planetary power generation conduit easily meets that $1 trillion market measure.
Absolutely. Yeah, I'm really excited about, oh, we have a visitor, a spider. Good thing I'm afraid of spiders. Get him away from my phone. Thank you. So yeah, that's okay. I won't kill him in front of people. There might be children in the audience. We're environmentalists. So anyway. So yeah.
Spiders are your friends.
Right there. He's going the other way now. I'm fine. Thank you. I have a visitor. See, even he's excited about the multi-trillion-dollar marketplace. So another question?
Oh, yes. I have the microphone, so I can ask the question.
Yes, sir.
The kerosene and now methane being the fuels, fuels, those would, I guess currently they are fossil fuels, but in a greener regulatory environment, would you be switching to the
gravity waves?
Gravity waves, really? Ah, okay, excellent.
You got it. You got it. So,
now, is there a chance like of liquid oxygen, liquid hydrogen?
Yes, absolutely. In fact, we are, it's been in the news. We've been working with the United Launch Alliance on the early stages of a liquid oxygen, liquid hydrogen engine development program that we hope potentially could replace the RL-10 upper stage and the Atlas and the Delta. And that's a very lovely engine size for going orbital one day. But yes, yes, sir. Whoever's got the microphone, yeah. We'll get to you next, I promise. Thank you. Yes.
So a couple times you've mentioned regulation, either FAA, ITAR, MTCR. I was just wondering what you thought the biggest problems with regulation are right now and what kind of their impacts are on the industry going forward.
That there is regulation. That's the problem. No, actually regulation is good when done right. I think I'll sort of answer the question in the medium, or sort of the, sort of now, the future, or, midterm and long term. I think immediately the thing that if it keeps me awake at night is this issue of export licensing and the definition of a vehicle that is certainly much less lethal than a Cessna 172 being declared a defense article. Okay? That I think is just, there's something wrong. And where that comes from, it's people are trying to do their jobs and being very well-meaning. But there was a piece of legislation passed in 1989, 1990, whatever, when they declared satellites on the munitions list. There were some issues with someone helping get satellites launched better from China, and Congress got mad. And we're in what we're in now. So that's the thing that I worry about. ITAR reform is very important. President Obama has started an initiative on that. And across the board, I think Republicans and Democrats alike are are supportive of it, but at the same time, there are members of both parties that are against it. And so you're talking about, I think the estimate is 600,000 jobs have been lost in the aerospace industry since the implementation of this. You have people out there selling non-ITAR satellites and services that specifically, so the global market is closed off to many of our industrial companies here in the U.S. So it's a big problem. And what it's done is also it's drastically impacted the industrial base and supplier base for our military as well as our civilian government and aerospace, civil aerospace industry. The sort of the tier 2, tier 3, tier 4 supplier market is, people have described it as decimated. The mom and shop, high tech, precision machine shop market is challenging, to find what you need out there sometimes. The little bits and pieces and widgets that are now on the ITAR controlled list, where they used to sell the bits and pieces of widgets, globally, well now they can't sell the little bits and pieces and widgets globally anymore, and the market is so small that they can't survive. So it's been a big problem, and they're trying to fix it now. So that's my sort of short-term thing. Midterm, we have a thing that's called the moratorium on regulation of the suborbital industry. It was passed through the Commercial Space Launch Amendments Act of 2004. It was just extended to 2015 from 2012. We would like to see that extended basically 8 years after the first commercial launches of suborbital vehicles with paying participants, because we think we need that runway of experience and history before the FAA starts loading on the beginnings of a more stronger regulatory regime. And so we'd like to see that. So it's sort of a midterm thing. Long term, I don't know. Yes, sir.
This $1 trillion that you estimate the capacity of this market, it's a nice round number.
Yes.
How was this number calculated? On the basis of what assumptions? And how do you see it as rather conservative or maybe way too optimistic?
It's a provocative number. It's a number to get you here. It is a number that I think is reasonable. If we look at what? Oh, the question was, where did the $1 trillion number come from? How is it derived? What were the sub pieces, et cetera? And what I'm saying is, it is a nice big round number. It's a provocative number. It's a number that we would all hope that is accomplished. But I think it's reasonable, and it could be multi-trillion. First time you pull back 4 Platinum Asteroids, well, number one, you're going to crash the platinum market. But someone's going to make a lot of money if they do it right. So, but saying that, if you look at you can see where it's coming from. If you see some of the sub-elements of what could be enabled if you have low-cost access to space, whether it be space-based power generation, whether it be putting on the orbital fuel depots and flying up liquid oxygen, liquid hydrogen on a daily basis for future exploration missions for NASA, whether in going to the moon, mining regolith, and creating outposts. There's a variety of things that people have said. And of course, the applications that are going to happen in space, people come to me with ideas that are I never imagined, but it happens. I sat on a committee that judged exploration business ideas at MIT for the 150th anniversary, and I was with Mike Massimino, one of the astronauts, and a couple other guys. And the 4 or 5 ideas for exploration businesses, one of them was really interesting. It was, with low-cost launch and appropriate landers, you basically put a number, say 20, 50, whatever, small rovers on the moon. And you connect them with a data link, and you can drive the rovers from your home PC and explore the moon yourself. And if you start thinking about the technology, you got the Google Lunar X Prize, and they're giving away however many, $20, $30 million to go do this, but that's to drive something 150 yards and shoot video back to Earth. But I could see that potentially happening if we've got $100, couple $100 cost to low Earth orbit, and then and somehow getting things to the moon. So who knows what people are going to come up with in fun? But I think if you just look at the big rocks, you know, power generation, on-orbit fuel depot, some of these other big ideas, they quickly come up to $1 trillion. So, but I didn't do a scientific study by any stretch of imagination. I was just being provocative to get you in the room. So, oh my gosh, you aren't allowed to ask a question.
It's not a question.
Oh, okay.
Addendum to Andrew's answer on the green fuels question. When we were testing with methane, we got it from Antelope Valley Waste Management. They reclaimed it from their landfills.
Yeah. So there you go. Good. Thank you. Good addition. Okay.
So I'm just curious. It's a kind of a quasi-regulatory question. You're in Mojave at the airport there, right?
Yes, sir.
And so you're kind of squeezed between China Lake and Edwards.
Yes, sir.
What is your footprint for your flight trajectory? Is it real small, or are you going to get into, or are you going to move when you start having a lot of these?
All the way to Arizona and back. No, I'm just teasing. It's not that far.
Yeah.
What is the footprint? It's
about out to Lake Elizabeth and back.
So he said it's out to Lake Elizabeth and back. Sort of a stone's throw around the bend, over the corner. So, but it's not too far. Yeah, 30 or 40 miles. Oh yeah, we go up and we come down. Yeah, like I said earlier, the cross-range capability of this vehicle is very low. You would have much more luck, you know, getting in a Cessna 172 and going someplace than trying to go someplace except for up and down with us. So. Yeah. Yeah. So, other questions?
Yeah, if we have any more questions, I'd encourage you to come up and talk to Andrew. Andrew, we have here a special spider killing device that doubles as a coffee mug, so hope you can use that in the future in your office.
Oh, I'd like that a
Need
lot.
calls.
Thank you very much. I
Please-
appreciate that.
Please join me in thanking you.
Thank you. Thank you. Yeah.